What's up, Summer Ridge? This is Tanner. I'm one of your math tutors this summer. I'm going to be going over problem number 10 from your exercises for word problems because that is one of your more complicated ones. So now we can go through a step-by-step process. So let's go. Okay. So first we have Richard, who's going on a 210 mile trip. And he's doing this in two different sections. The first part he travels at, let me double check the problem, at 60 miles per hour for part one. Whoops. So he goes at 60 miles per hour for part one. Now for part two, he goes at 40 miles per hour. And we know that his whole trip took 4 hours. Now that is all the word problem, all the problem gave us. And now we need to figure out, during this time right here, how many miles did he go? So let's set up our table. So you have your distance equals rate times time. We'll cut it up into our sections. So we'll make this row part one, this row part two, and the last row the total. And just a heads up, we're not going to need that box. Okay, so first, off the bat, we know his total distance was 210 miles, and his total time was 4 hours, and the rates were 60 and 40 miles per hour. But we're trying to get here. And to find distance, we need both the rate and the time. So what can we do for that time? One assumption would be to go ahead and do something like this. Oh, I already used that color. And just put an X for both time slots. However, we don't know for sure that Richard went for the exact same amount of time for each part. So we can't say that these are equal anymore. Instead, what we have to do is do, say, X for part one, but then Y for part two. And what this means is we have to do some more algebra. So when we talk about totals, totals are made up of this different parts. So when we look at the total of 4 hours, that will be made up of X plus Y. Oh, let me back up really quick. The setting up of the table from what you know is part one. Now part two will be to solve out for this Y and set up the rest of the problem. So to get Y by itself, we'll do the minus X and get Y equals 4 minus X. So now we can take this and substitute it in for a Y, giving us this. Now we have what we need to solve for our distances. So now we can get 60x and 40 times 4 minus x. So that was part two. Now part three is to go through and solve for x. So the way we do that is we have our total distance, which is made up of the distance from part one and the distance from part two, which is 210 equals 60x plus 40 times 4 minus x. Now we distribute the 40. Combine like terms. Move the 160 over. And then solve for x. And now we end up with this. Now, this might look like we're done because we solved for x, right? But what were we looking for again? The total distance traveled in the slow speed. So what we have to do, get rid of this. Give it a second. It's a little slow. So now we'll go back and let's use this color. So now let's just take, well, we have to look at part 2. So now we want to find the distance at the slow speed of 40 miles per hour, which was 40 times 4 minus x. And if you remember, our x was 2.5 or 5 over 2. So we can plug in 5 over 2 for x, and we get now remember that the 4 is over 1, and using least common denominators, we can turn that into 8 over 2. So now we get 40 times 3 over 2. Can cross this out to get 20 and 1, which gives us 60 miles at 40 miles per hour. And that would be your answer. I hope this helps. Let the tutors know if you have any other questions, and keep in mind this thought process will probably come up in many of the other problems. Good luck with your studies.